Hey everyone, welcome. Today we're diving into something that's, well, a little scary, but also super interesting. We're looking at a huge flaw in modern AI, how the very thing that makes them so smart, their memory, can be turned against them to leak our most private information.
All right, before we really get going, just a quick heads up. This is part 2 of a 5-part tutorial from Virtualization Options LLC, and it's all for educational purposes. Now, I really recommend you check out the full course document in PDF format. It has way more detail than we can possibly get into here. Think of this as the highlight reel.
So, what's on the docket today? Well, think of it as a bit of a world tour of some pretty serious security breaches. We're going to look at real-life examples from healthcare, from the high-stakes world of finance, and even inside corporate offices to see exactly how these AI models can be, well, tricked into spilling their guts.
So, what's the core problem we're dealing with? It's kind of a paradox, really. The very thing that makes an AI so incredibly smart, its ability to just soak up massive amounts of data, is also its Achilles heel. See, when an AI learns, sometimes it doesn't just learn, it memorizes. And anything it memorizes, well, it can be forced to leak. And this opens the door to a whole new type of threat. We call them PII extraction attacks. What's so wild about these is how they work. The attackers, they don't need to be elite hackers breaking into a database. Nope. They just talk to the AI. By asking the right kinds of tricky questions, they can literally coax the model into spitting out sensitive personal info it memorized during its training. All right, let's make this real with our first case study. Picture this, a brilliant cutting-edge AI designed to help doctors spot cancer early on from medical scans. I mean, this thing was trained on 500,000 patient images, making it super accurate. A total lifesaver, right? Well, it turns out it was hiding a pretty dangerous secret. So, how'd they do it? They used something called a model inversion attack. Now that sounds super technical, I know, but just think of it like playing a game of hot and cold with the AI. The attackers would feed it these blurry, totally made-up images and just watch how confident the AI's answers were. By tweaking the images just a little bit here and there to get the AI to say, "You're getting warmer, warmer," they were actually able to reconstruct the original crystal-clear patient scans the AI had memorized. It's wild. And the scale of this? It was just staggering. We're not talking about a small glitch here. The private medical data of 47,000 patients was exposed. This tool that was built to heal people became a massive, massive liability. And you better believe the consequences were severe. A federal investigation kicked off under HIPAA, that's the big law protecting patient privacy, and it ended with a $2.3 million settlement. So this wasn't just some tech problem. It was a full-blown, incredibly expensive legal and financial disaster. And you know what? This perfectly illustrates the core problem we're talking about. There's a quote from the healthcare network's own chief privacy officer that just hits the nail on the head. They said, "The model's accuracy gains came at the cost of memorizing patient data." It's that classic brutal trade-off. Do you want more accuracy or do you want more privacy? Okay, let's switch gears and jump into the high-stakes world of finance. So there's this huge multinational bank, and they've got an AI that's an absolute genius at spotting fraud. It's saving them millions. But of course, attackers found a way to turn this guard dog into an informant. They used it to figure out exactly who the bank's richest clients were.
And their strategy was just so clever. It was a whole step-by-step process. First, they put together a list of potential high-net-worth individuals. Then they generated a bunch of fake transactions that look like things these VIPs might buy. They fed all that fake data to the AI, and here is the key. The AI would respond just a tiny bit more confidently when the fake transaction matched a real customer. By looking at these subtle little tells, the attackers could figure out with over 85% accuracy who was a customer and who wasn't.
So what happened next? The fallout was immediate and devastating. Now that they had a confirmed list of VIP clients, the attackers launched these super targeted phishing campaigns. And because the emails looked so legit, they worked. The result? A staggering $3.7 million was stolen in fraudulent wire transfers. It's a perfect example of how a simple data leak can directly fuel a massive heist. Okay, now let's bring this threat a lot closer to home. Let's talk about the modern office. A Fortune 500 company rolled out this slick AI assistant, to help employees write emails, schedule meetings, the usual stuff. It was trained on millions of internal company emails to make it really, really helpful. But that very same training created a huge, huge blind spot. So this is how it all fell apart.
It started when a security researcher just noticed some weird behavior when they asked the AI questions about itself. This led them to develop these things called prompt injection attacks, basically clever ways to trick the AI into ignoring its own safety rules. And what happened? The AI was tricked into coughing up internal email templates, which exposed the names, phone numbers, and even the reporting structure for more than 8,700 employees. And here's the kicker, the investigation later found that 37 employees had already accidentally triggered small leaks without even realizing it. Okay, so far we've been looking at pretty targeted attacks. But what happens when this kind of vulnerability hits huge consumer industries? Let's look at our last two case studies, one from telecom and one from retail, where the scale of the damage just explodes, going from thousands of people to millions. First up, a major telecom provider. They were using an AI to transcribe and analyze customer service calls. But the model was what we call overfit. That's a technical term, but it basically just means the AI didn't just learn from the data, it memorized entire conversations word for word. So, attackers figured out they could just feed the AI the beginning of a common phrase you'd hear on a customer service call, and the model, like a creepy autocomplete, would just finish the entire rest of the conversation it had memorized. In doing so, it exposed the full records. We're talking name, phone number, address, everything for over 23,000 customers. And you can guess what happened next. The regulatory hammer came down, and it came down hard. The company was slapped with a $12.5 million settlement. It's yet another brutal reminder of just how much it costs to get AI security wrong. But the damage doesn't always stop with fines. Our last example, a huge international retailer, really shows how there can be two totally different kinds of damage. First, you have the privacy loss. Attackers were able to reconstruct the entire purchase histories for 125,000 loyalty program members. But then, there's the second, and maybe even more devastating kind of damage. Their competitors use the exact same technique to steal the company's secret sauce, all their data on customer segmentation and pricing. That's a loss that was estimated to cost them up to $60 million a year. And Wall Street? Well, the reaction was swift and it was brutal. The company's stock price tanked by 8.3% as soon as the breach was made public. That single drop wiped out $2.1 billion, with a B, dollars in market cap. This just goes to show you, the damage wasn't just about privacy or losing a competitive edge, it hit the company's value right at its core. So, after that whirlwind tour through some pretty disastrous breaches, let's take a step back and connect the dots. We've looked at healthcare, finance, telecom, retail, all these different industries, different AIs, different attack methods, but they all share one single fatal flaw. The pattern is just crystal clear, isn't it? An organization deploys a powerful AI and trains it on really high-stakes data. In the race to make the model perform better and better, its ability to memorize is seen as a feature, not a bug. Then attackers come along and exploit that memorization using subtle, clever questions, not complex hacks. And the result, every single time, is a catastrophic leak of either personal information or intellectual property, which, as we've seen, leads to huge fines, financial loss, and a total loss of trust. And all of this leaves us with a really big, really critical question to chew on. If the very thing that makes AI so powerful, its incredible memory, is also its greatest vulnerability, how in the world can we ever trust it with our most sensitive data? That's really the central challenge we're all facing as we bring these amazing tools deeper and deeper into our lives.